Thank you, everybody, and thanks for being here. I'm very excited to present the preliminary results from this project that I was very lucky to be a part of. It's an empirical audit of construal level theory, and I'll explain what that is. But empirical audit is this new approach where we essentially take a randomly selected sample of studies from a literature and replicate the studies to assess the evidentiary value of that literature. So before going to the theory, I would like to mention who my collaborators are. Not working. Okay, I'll try. Okay, so the project is part of a course that was led by Leif Nelson and Don Moore here at Berkeley, and you'll hear from Don in the next panel, and Joe Simmons at UPenn. The course is a doctoral course called Replicability, Reproducibility, and Evidence in Behavioral Sciences, and we had the great luck to work with wonderful 20 students, mostly doctoral students, but some postdocs. 2 of them are here. And they did most of the work on this project, so they deserve most of the credit, and I'll take credit for any errors. So before I get into, I just want to mention what construal level theory is. So it's a psychological theory proposed by Nira Lieberman and Yakov Trope, and it essentially posits a positive reciprocal relationship between psychological distance and construal level. So how abstractly you represent something in your mind. So if you think of psychological distance as sort of, going from distal to more proximal, more near, things that are sort of psychological, objects or targets or concepts that are psychologically distant are construed at a higher level, so more abstract, versus things that are more nearer, psychologically nearer, are construed at a lower level, more concretely. And you can sort of think about it this way, right? If I ask you to think about your day tomorrow versus what your day will be like a year from now, right? I hope that you'll be able to think about your day tomorrow a lot more concretely than you would a year from now. So that's sort of the core tenet of the theory. There are 4 sort of subdimensions of the theory. Temporal, so this is when something happens. Spatial is where something happens, near versus far. Social is social distance, so how similar or dissimilar somebody is to you, a target. And hypotheticality is the most fuzzy one, which is about how likely something is to happen. So how do we choose the topic? We asked the students, all 20 of them, which are some topics you would like to consider replicating for the project. There were 51 options given. We narrowed it down to 7 just based on how feasible they would be to do and if there was a large enough literature that we could replicate. Students rated all options, and this is construal level theory came out at the top. And we generally thought that it was, an interesting theory, large but definable literature. We could replicate the studies online. All the studies were conducted online. And we did think that it had some evidentiary value, so we wanted to test that out. How do we choose the paper? There's an excellent bibliometric analysis of all CLT papers published between 1994 and 2020, published in Psychology and Marketing. And we started out with 894 papers. They were filtered initially based on journal rankings. So there's some filtering of quality there. After that, we read all the abstracts and went down to 504 papers. So they would have had to contain experiments, so they couldn't be, observational field studies, longitudinal studies. We could replicate them with fidelity online and did not require a sample that we could not replicate or context that couldn't be replicated. After that, we filtered it down even more to 5 of the highest cited papers from each year that we had papers for. And that brought us down to 82. So from all the papers, how do we choose the studies? So students read all 356 studies from the 82 articles. Papers had between 1 to 13 articles. Median was 4. They've initially rated 203 experiments as replicable, and then we filtered out, we resolved the maybes. We took some out if the design was too complicated, we could not replicate the stimuli, things of the nature if they were not experiments. And we were down to 231 experiments from 70 articles. From that, we randomly selected 20 of them to replicate. These were the 20 studies that we ended up replicating. We reached out to the original authors, let them know that we're replicating their studies, asked them, for feedback, if they could share their materials or code or any other information that they could share with us to help make, allow us to do the replication as well as possible. This was very nice. Most of the authors responded to our requests, or they responded to our emails. Only 3 did not, and they were generally very helpful. They shared their materials when they could, and they were pretty responsive. A lot of them mentioned modifications that we should make. We ran 3 pilot tests, 2 based on author recommendations. We had original materials for a good number of them, more than half. Some of them, the author shared them. Some of them were available publicly, either on OSF or their appendices were detailed enough that we could replicate. We could get the original materials. We did not have original data for any of them, just for 1 of the studies, and original code for 2 of them. All right, so I mean, the methods, we just replicated the studies, so there's that, but everything was pre-registered. Students were paired up, so there was internal review of everything, of the pre-registrations, the materials. I was reviewer 2 for everybody. And then we pilot tested 3 of the replications, as I mentioned. Half of the studies used data blinding during the analysis. And if that's new to you, I'll briefly explain what that is. So this is a technique that's used often in physics, cosmology or particle physics, where what you essentially do is once you have the data, when you're writing the analysis, you essentially blind yourself to the results so that you can write the analysis without your biases polluting any decisions you might take during the analysis. So in our case, our designs were pretty simple, so it was easy to do, but you can add random error to your values, or you can shuffle your independent variable labels and stuff. And so this just allows, it's an additional guardrail to pre-registration to make sure that we're not biasing our results in favor of a positive result. So if you're interested, I'm happy to talk about it. It's a pretty cool technique, I think. So just to give you a flavor of what the studies were like, I'll just briefly explain one of them. So this was a study from 2005. It's a 2-cell design. Participants had to choose between 2 brands of popcorn for a party. We're not saving any lives in social psychology. So participants either had to pick the brand either for a party that's happening next day or 6 months from now. These were the 2 brands that they were given. So brand P and brand Q. So there were some attributes that were aligned. They were sort of talking about the same thing. And in the bottom, you'll see ones that are not aligned. So they're talking about different things. Brand P was better on aligned attributes, and brand Q was better on non-aligned attributes, or non-alignable, I think they called them. The main dependent variable was just their preference for the brand. And they had to allocate 100 points between the 2 brands. That's the main DV. Their hypothesis was that when making decision for a distant outcome, participants will be more likely to weigh the non-alignable attributes a bit more. That's what they found. The mean was higher for the distant future. So that's the original result. So this is the preference for brand Q. When we replicated the study, we did not find the same result. So not a lot of difference between near future versus distant future in allocation of preference. So this is foreshadowing the results, and I'll show you all the results now from the 20 studies. So these are the effect size, the replication effect size plotted against the original effect sizes. Anything above the x-axis was in the expected direction. Anything below is in the unexpected direction. So red is not significant and blue is significant. So we had 19 effect sizes were smaller than the original, 7 were directionally opposite. Only 1 significant replication, and the effect size was actually just very slightly larger than the original. And we had 1 other significant finding, which was directionally inconsistent. And I'll actually describe both of the studies to you. But before I do that, if Leif and Joe were here, they would say that averaging these effect sizes is sort of meaningless. The mean is meaningless, but this is the average effect size for all 20 studies, so a little less than 0.1. So these are, again, the effect sizes of the original studies and the confidence intervals, and all the effect sizes are in R, so correlation coefficients. Original N's, the sample sizes, and these are the replication effect sizes, the significant one at the top and then the directionally opposite one down at the bottom. And we collected 2.5 the sample size of the original studies. In terms of power, the one study that replicated at 100% power, the rest of them, so this is the original study's power to replicate the effect size that we got. The mean is about 15%, median is 7%, so not great. If we look at the upper bound of the confidence interval for the effect size, the replication effect size, these are the estimated power for those, so a little bit better. And these are the sample size we would need to detect with 80% power, those effect sizes. So I'll describe these two studies to you, starting with the one that was directionally opposite. This one's a bit of a mystery. We're going to check for some errors to see if we made a mistake, but yeah, it is what it is. So originally it was a within subjects design with 12 participants. Participants completed an IAT task with words related to temporality. So this was whether something was proximal or distal. So these are the actual stimuli. So words popped up either like a second, a minute now, or a year, a decade, or last year, and also high versus low construal. So these were either items, so things like hammer, beat, poodle, versus categories, so vegetables, dog, animals, clothes. So in congruent trials, participants saw a word pop up, and the categories on the top were either congruent, so this is near future, so proximal with the items, and the distant future with the categories. So this is a congruent trial, and they had to categorize the word that popped up. In incongruent trials, the near future was paired with the categories versus the distant future with the items. The same thing for objects or categories. So in the original study, they hypothesized that participants would respond faster to congruent trials. And this is what they found. So the response time was faster, so shorter for congruent trials versus incongruent trials. This is their effect size. Mean difference was 116 milliseconds. ITD score, which I think is like a distant relative of Cohen's d. So you can think about it that way. Pretty big effect size, 0.77. This was our result in the replication. So we actually found that congruent trials had, slower response time than the incongruent trials, which, it's directionally opposite. Also not a pretty sizable effect size even there. So it's a bit of a mystery. And then finally, the study that we did replicate pretty successfully. So it's also within subjects design. Participants evaluated 3 scenarios, either high level, low level, or neutral. That was a control condition. And there were 2 construal levels, why or how, and participants rated both of them. And it'll become clearer what I mean when I show you an example. So for the why, participants answered, like, when people consider why they perform an action, then think about the purpose or the meaning of that behavior versus how, like, how would you do it, the steps involved in doing the activity. And the primary dependent variable was the usefulness of thinking about why versus thinking about how. These were the 9 scenarios. So for high level, they thought about either recycling or delay discounting or choosing between negative versus positive feedback. In low level, it was things like proofreading, Stroop task, or a basketball throw. And in the control condition, it was things like meditating and choosing a movie. And so this is an example of something that they read. So please begin by imagining that you are taking part in a task designed to test your writing ability. And this task requires you to read passages and then check for misspellings. And your task is to correct the typos. So this is a low-level task. And they answered, to accomplish this goal, how helpful it is to think about the why versus how helpful it is to think about the how. So they answered the how and the why questions for each scenario for all 9 tasks. So the hypothesis was that participants would prefer high-level strategies in high-level scenarios and low-level strategies in low-level scenarios. They did find a significant interaction. It was a 3x2x2 mixed ANOVA because they also had order in which they showed how versus why, but we are only interested in this interaction. That's sort of the main thing we're interested in between high and low-level task. And when we replicated it, it was one of the cleanest replications I've seen. We find the exact same effect with an effect size that's a little bit larger. And Sophia's right there. She was the replicator for that study. So I don't have great conclusions. We're still, like I said, wrapping up this project. But I will, we replicated 1 out of the 20 studies successfully. But I will say that as with any replication, we can't really say anything about the theory itself, but that about the studies. And here I will speak mostly for myself. I think just going through the studies, looking at the way the experiments were run, I will say that it seems like the theory is certainly elegant, and I think the hypotheses are sort of plausible. But then when you look at the way it's actually measured, I don't think it sort of matches up to how complex the theory is. So the paradigms that are used to study it might need revisiting. And I will also acknowledge that the original authors were generally very, very, open and helpful. So, I mean, some of the papers were from 2006, 2008, and researchers dug into their old hard drives to find materials for us. So I think that was pretty great. And that's it. Yeah. So thank you.
Brilliant work, Smriti. Brilliant. Love it. Love it. This audience might be interested to hear about the discrepancies between the empirical results that you just shared with us and the algorithmic replication predictions produced by so some of you may have read this paper in the Proceedings of National Academy of Sciences by Yu Yang and Utsi in 2023 that offered an AI model to help predict the replicability of published papers.
Yeah, so we tried to use that algorithm for our papers with a caveat that we ran the algorithm for all studies in those papers. And I think maybe we'll get a better estimate if we did it just for the studies we replicated. And the number we got was 0.493.
Isn't the algorithm predicted 49% probability that the studies
would replicate? I'm not sure, Don. I have a good answer to that. Maybe we're just bad at conducting experiments. That could be one thing. Or maybe it's certainly possible that the way studies are described in papers or the way the results are presented, right? It doesn't really align with how robust the findings are. Yeah. Why do you have to give me a hard question, Don? That's yes.
Thanks a lot. That was striking. And the figure you showed with the effect sizes and then your guys' replications is like a kind of instant classic figure, I think. One of the things that you said early on is, I think, if I interpreted the table right, very few of the original authors shared the original data and code with you. So you were kind of relying on what was in the published paper and then doing the replications and contrasting it. And I just wonder, given what we know about the poor rates of computational reproducibility that we've seen in field after field, I think it would have been pretty interesting to get the original in code and data, if it did exist, to see maybe there are errors in that code, problems with the data. Maybe if you tried to just rerun their analysis with their data, you would have found something different than the published paper. That's definitely been the case in so many computational reproduction exercises. So I do wonder how much of the gap between the original result and what you found is due to that, combined with all the other publication bias problems we've found.
Yeah, it could certainly be. Although I will say, I mean, a lot of the studies, again, are, from early 2000s where people probably did not do data analysis the way we do it, right? If you're doing something in SAS or SPSS and you're not used to writing scripts, maybe you don't have stuff that you could share with people in a way and a lot of that might just be old, where people don't keep track of it, right? So I do think it's harder from studies that were conducted a long ago, but hopefully, now that we're in a phase where people are becoming more consistent about writing code that could be reproduced, it is certainly possible that some of our discrepancies could be because of that. But yeah, it's hard to tell until we get to the phase where everybody's used to sort of writing code and then being able to share it. So, yeah. Yeah, Juliana.
2 quick questions. One, did you have the original authors sign off on the either materials or analysis or any part of the process, or were they just offering help in the beginning?
some authors were definitely more involved than others. So we had a few that really looked at the materials, offered suggestions, made recommendations. Maybe except maybe in one or two cases, we did sort of adhere to, sort of followed their recommendations. We did not reach out to them for signing off on the analysis. But definitely the materials we did share with them when we could to get their feedback. Yeah.
Okay. And then the second question is that since some of these studies were almost 20 years old,
Yeah.
was there any sense that you needed to update some of the materials kind of, could that have been part of any of the failure to replicate, do you think, just to speculate wildly about it?
Yeah, in cases where it might have been the case. So for example, right, one study we had where camera, like they had to evaluate a camera. So we did update the features of the camera right, so that it's not like, 200 megapixel or something. Is that bad? But yeah, so we updated it to match, current standards of things. Same thing with a computer. We had people evaluate computers. So we did our due diligence there. There were some other scenarios where participants it was like something tailored to college students or like things that would be sort of anachronistic now. We did update those to the best of our ability. And sometimes the authors also recommended that 2 of the studies we pilot tested were sort of based on that. Yeah, we should, change the scenario a little bit and just pre-testing them to make sure that they were, still, as you would expect. Thanks, Juliana.
Hi, I guess like my question is, what's the overall takeaway? How does your result change our understanding of the construal level theory?
Yeah, so I don't want anybody to go here like thinking that we're saying construal level theory isn't true. I think like I said, I might have a better answer once I've, finished the project and, sort of had some time to absorb everything. But I think the sense that I have now is just that the theory might not be, probably isn't being tested all that well. And even just an example, so 2 of our studies were IAT studies, and one of the authors, Barnon of the IAT study, he himself just sort of mentioned that, the studies from 2006, and he's like, we now are not sure about IAT test itself, right? What the results of those mean. So there's that, but also that he was no longer sure whether that was the sort of optimal way of measuring that hypothesis either. So we, of course, were sort of restricted by the, design. So we had to replicate it. But I think he was like, we're not sure if this is the best way to test it. So I think, people who are in this discipline might want to just think more about how to test their hypotheses sort of better and more rigorously.
Hi, thanks for that talk. I had a quick question. So I saw that the effect sizes at the end varied. I'm just curious about the whole process from the data you get to the final output. So the final output looks like it doesn't match. Were there analyses done along the path to kind of figure out where they start to differ? Like, was there some sort of exploratory data analysis done, like even just basic computations off of what they may have stated that did match what you got along the path?
So I'm sorry, what do you mean by so there were the original findings that were from the original papers, the original studies, and then our results.
Yes.
So we only replicated, so I'm just showing you the main results. So the key test of the hypothesis, the main hypothesis, and it was an exact replication of the way it was tested by the original authors.
What I'm wondering is like if there was any other like basic data analysis kind of presented like by these papers that like if you were to reproduce that to just kind of show that some parts of it kind of match, but like maybe the final, there's some gap, like we went from like start to end, but maybe there's some intermediate steps where they actually do match along the way.
That's something we could definitely do as we're sort of finishing up the secondary data analyses. But I will say, like I said, a lot of them are simple designs like 2-cell or 2x2s, 3x2s. So, right, you would just be simply comparing sort of means and then looking if that's the, if the main effect is significant or the interaction is significant. So I'm not sure there's a lot of room for like that many steps for there to be discrepancies, except for, hey, the means are just, not significantly different or in the opposite direction.
Gotcha.
Yeah, thanks.
I noticed in your original set of studies, there were some replications that you took out. Did you happen? I'm curious why if you were curious to actually replicate the replications, or if you took a look at those when you were doing your own replications.
Yeah, so the reason we took out the replications was because so an empirical audit like this has been done twice before, and I think just interpreting the results of a replication just becomes sort of complicated, right? Like, is it significant if it's a null, or is it significant if it's right, or if you say so? It just becomes a bit of a complicated to sort of have an average takeaway from everything if you have replications in there, because they become sort of hard to interpret. Like, when do you count it as significant versus not? So, I mean, so it's a subjective decision we made, and you can challenge it, but yeah, that was the reason. Yeah.
Yeah, thank you very much. I think that's really great work and absolutely plausible results, I think, for social psychology.
Well, unfortunately, yeah.
Yeah, so thank you very much for doing this. And what I think is really also amazing, it was brought up before, how, and I hope this is documented somewhere, how you made this many authors, original authors, engage with you. This is uncommon from everyone I know doing anything with meta-analysis or replications, that only 3 people don't respond out of 21. I think otherwise it's like the other way around. So I hope this is somewhere documented, what you wrote them and how you got them this engaged. So thank you very much for this.
Oh, yeah, thank you. Yeah, I mean, I sort of gave students a template, which, yeah, they sort of sent us, and, tailoring it to their studies. But yeah, I hadn't thought of documenting them, but I probably will. And I think what we wanted to do, which is sort of honestly reflect that we wanted to do the best job we could of replicating their study. And insofar as that they help us do a good job, that it would help us carry out the replication with fidelity. But we will make sure to sort of document that. Thank you. Yeah. Thank you, everybody. Yeah.